Yes, right. We are proceeding with the next problem. That's question number 3. This question is centered around objects on a plane. It's not exactly on an inclined plane, but it's coming with a different style, which we might also need to investigate. I can see a force being applied to push the object. Why can't I just imagine that it continues in this fashion? This is the horizontal surface, implying that these two angles are going to be equal in magnitude, 20 degrees. But the reason why I'm doing that is I want a 50 Newton force down the side. Let me erase so that we go through the problem before I proceed. A block is pushed along a horizontal floor by a force of magnitude. We have the force here is 50 newtons, and exit an angle 20 degrees to the horizontal. C diagram. Coefficient of friction between the block and the floor is 0.3. Given that the speed of the block is constant, that's what we want to investigate. According to Newton's laws, that's the second law, net force acting on an object is equal to product of mass and acceleration. But let's check here. If they tell us that the speed of an object is constant, we know that acceleration is going to be equal to 0. And when that happens, it means we are multiplying mass here with a 0. So overall, the net force acting on the entire system is going to be 0. What does it mean? When the net effect or net force acting on an object is 0, it implies that there's a balance between the positive side forces and the negative side, or the upwards and downwards. So I can proceed now to investigate our question. But what we are interested in with this constant speed is to find the mass of the object. So if I proceed my force here to the magnitude 50 newtons, angle we highlighted it as 20 degrees, then we can imagine that here we are going to have the parallel component of the 50 Newton force, and here we have the perpendicular component, because we're going to create a 90-degree angle such that this side we will have a component, which is the y component, of magnitude 50 sine 20 degrees. And along this plane, which is our x, we have a component of 50 cos 20 degrees. Then, whenever we have an object, there's a force acting perpendicular and upwards to the horizontal, which we call the reaction force. It helps us to calculate friction. Then, also there's a force pulling the object towards the center of the earth, which we refer to as weight. Weight is calculated as product of mass and acceleration due to gravity. So, if I'm told that this object is got an acceleration of 0, it means there's a balance between this forward force which we enlisted here and the frictional force which we anticipate will be acting in the opposite direction. So if I do my substitutions now, I'm saying 50 cos 20 degrees is equal to the frictional force, which we know friction is calculated as mu r. We have our mu here, that's our mu. What's missing is our r. So mu is going to be 0.3 multiplied by the value of r. But what's our r? R is an upward force which is balancing the downward forces. And for our case, we have two. One is here and the other one is there. So inside the brackets, I'm going to substitute the value of Rs, because one component is mass times gravity. And gravity we know is 10. So this will give us 10m plus this other component, which we are told is 50 sine 20 degrees. Then I'm looking for the value of m. So this is what I'll do next. Um, Let me scroll up a bit so that we have space for the calculation. I want to get rid of 0.3 because I'm interested in what's inside the bracket. So I'll divide both sides by 0.3 so that this cancels. I remain with 10m plus 50 sine 20 degrees. The other side, I'll need a calculator. So let me push my calculator this side so I can visualize the calculation. I'm interested in this calculation where it's 50 cos 20 degrees divided by 0.3, giving me 156.6 1.15, which I can round to 2 decimal places, 156.62. So let me drop that. All this is equal to 156.62. But I'm interested in m, so I'm going to transpose 50 sine 20 to the other side. So I'll overall have 10m being equal to 156.62 minus 50 sine 20 degrees. Pick my calculator again. Let me push it this side this time around. I have 156.62, which is still appearing there. So I can come to say minus from my answer 50 sine 20 degrees. This will take me to 139.51. But remember, all this is equal to 10m. So if I want m, I'm going to say, right, let me divide both sides by 10. So when I come to divide here by 10 and that side by 10, what it will imply is my m will be, let me take my calculator and divide the answer there by 10. The result is going to be 13.951. So I can say the mass of the object is 13.95 kilograms. I think that's all we needed on this problem. Thank you folks for watching.